And so we're going to try to set up this integral. To find volume, just integrating one. And we're going to set it up first in order dz, dy, dx. And so what I need to do first is find the bounds for z kind of below and above. And so if you drew this picture, you would sort of know that the plane sits above the bowl because the bowl touches the origin and the plane flies over the origin. Or if you read the sentence that they gave you, it's below is the bowl and above is the plane. So however you arrive at the conclusion, I know that the bounds for z are going to be that below it's bounded by this bowl, x squared plus y squared. And above it's bounded by the plane z plus 2 x equals 3. So that's z equal 3 minus 2x. So there's some kind of curvy on bottom, flat on top shape that we're finding the volume of. Your textbook on page 969 has a picture of it that's better than what I've done here. So now we have to find the bounds for y. And this is going to be the part where we think about the shadow of our surface down into the xy plane. And this can be a little bit difficult to think about because before there was only one like object to think about shining down on this plane, for example. Now there's two objects. There's the bowl and the plane. And we have to remember that we only care about the part where the bowl and the plane kind of sit together. So the plane could continue on forever, but I actually stop drawing the plane once it runs into the bowl. Kind of, here's my bowl, and then my plane is slicing through the bowl, but I wouldn't keep thinking about the plane beyond that point. And so if the light is up here and it's shining down, it's getting caught by the plane and then cut off whenever the edge of the bowl happens. And so before, sorry, I keep going back over here, our bounds were always when this surface cut into the xy plane, z equals 0. Now, the kind of widest point of our surface, the part that gets projected down into the xy plane, the thing that casts a shadow, the edge of it is going to be defined by when the bowl and the plane touch each other, not when either of them touches the xy plane. So I care about when these two things run into each other. So I could go ahead and say, okay, that happens when y is the square root of 3 minus 2x minus x squared. And that for sure is something that I don't want to plot, but I will just because. This is going to be a circle because it has x squared plus y squared in it. And the minus 2x means that my circle is offset like this. So, yeah. Okay, so the center of the circle is like over here. So the projection of this plane cutting into this bowl pushed down into the xy plane looks something like this. We can go back and figure out those actual numbers later. And if this is our whole shadow, then again, going back to our example before, not this example. This example, we always made the argument, oh, there's square roots. It could be positive or negative, but I only hold on to the positive one because I'm ignoring negative y's, x's, etc. But in this example, we're not told that. We're just finding the volume of this whole solid, not restricted to the first octant. And so it's important to remember that when I take a square root, I have positive or negative branches. The positive branch is the up top part, and the negative branch is the down below part. So my lower bound for y is down here, my upper bound for y is up here. And then now is the part where I actually have to figure out the bounds for x. So if I squish this circle down, or imagine casting a light, however you want to think about it, the furthest left, furthest right bounds for x are what I need next. So to do this, I'm going to do so all I did was I'm looking at the same circle equation, but I've moved all the x's to the same side. And then I'm completing the square. If I do x plus 1 squared, that gives me an x squared plus 2x plus 1. So since there's a plus 1 I haven't accounted for, I better add it to the other side too. So I get 4 is equal to x plus 1 squared plus y squared. That's 2 squared is equal to x plus 1 squared plus y squared. Okay, so why did I do this? What I'm looking at is a circle. Didn't want to erase my bad circle, just wanted to erase my bad line. Okay, so I'm looking at a circle, and now from this equation, I know that this random offset I saw in x is that it moves over 1. The center is moved to the left 1, so at negative 1. Y center isn't moved, so I'm still on the x-axis. And then the radius is 2 everywhere. So specifically here, negative 1 over 2 more is negative 3, and negative 1 to the right 2 is positive 1. So the bounds for x are that it falls between negative 3 and 1.